So a little bit about myself. I'm a software engineer at Rover. For those of you who are not familiar with Rover, it's an online marketplace for pet services like dog walking or dog boarding, grooming, things like that. And Rover actually got started about 8 years ago at a startup weekend as a Django project. And so we've been with Django for many, many years. And it has continued to serve us well. So today I'm going to be talking a bit about prefetching. And over the last couple of years, there's been a number of times where we've encountered some things in our code where it was maybe not necessarily the best, but digging down into Django's internals and learning about how the prefetch-related implementation works, we were able to come up with, I think, good solutions to the problems we were having. So today, I'll give you a brief overview of what we're going to be talking about. So the very first section, we'll be talking about N+1 query problems. This is sort of the main thing that prefetch related is trying to solve. So it'd be good to just make sure that we're familiar with that, so we know, what we're trying to avoid. The next section is sort of a prefetching under the hood section. And so the things that I hope to cover here are things which A, are not sort of covered by the Django documentation, and B, focused on the things where the Django's prefetch-related code interacts with sort of external code. So these are the types of things that you'd want to know about if you were designing some code to interact with Django's prefetch-related system. And then, given that, one thing I want to say is that section will be probably fairly brisk. And it is not necessarily my intention for you to sort of internalize every kind of line of code that we go over in %. The main thing that I want to accomplish there is just to sort of call out what the main sort of moving parts are with prefetch related and how they interact. So even if you don't quite understand a section of code or forgot what I covered earlier, that's not a big deal. And so then, given that, knowing about how prefetch related works, I'm going to go over a series of what I'm calling case studies. But these are scenarios where what Django provides out of the box maybe isn't necessarily a good solution. And so with a little bit of work, we can use Django's internals to, say, come up with something better. With that being said, what do talks are for the audience? And so I sort of wanted to cover at the beginning, what do I want you to get out of this talk? Because I think knowing that maybe will make this talk more effective for you. So given that this is a talk about prefetching, I want you to come away with an understanding of the key points with respect to how Django implements prefetching. But I'd also like you to sort of think about your own, the code that you work with on a day-to-day basis and what sort of problems or things you've encountered with respect to, say, data fetching or N+1 query problems. And then finally, I'd like you to see how you can use, say, knowledge of Django's internals to improve your own code. And I think more generally, one way that we can sort of grow as engineers and become better software developers is to kind of dig into the sort of libraries or frameworks that we depend on every day, especially if we encounter something where, it's not behaving as you're expecting. Then that's a great time to say, hey, maybe I'm going to set aside some time to really dig in to see what's going on there, even though it may be quicker to, say, check Stack Overflow and find some quick solution. But I think being able to sort of dive down into the code that you work with is a great way that we can become better software engineers. So first thing, like I said, I'll talk about n+1 query problem. And so what is this? So the n+1 query problem is what I'm calling a data access anti-pattern. And this commonly occurs when using ORMs. And so how it works is an initial database query is done, and it fetches multiple rows of data. This is the +1 in the n+1 query problem. And then for each of those rows, an additional query or queries are done to fetch more data related to that particular row. And so this is the n queries in the n+1 problem. So for example, if in Django we run a query to fetch a list of 100 dogs, and then for each of those dogs, we want to, say, display the name of their favorite toy. Well, if you sort of do it naively, then you may, get into a situation where you run 100 queries to fetch all of that data. And if each database query, say, takes 10 milliseconds, then you're in a situation where you've already are spending 1 second of time during the request response cycle just to execute all of these database queries. So that is what we are trying to avoid. So what do n+1 query problems look like? So I'm going to go over a couple examples of how these commonly come up in our code. So let's say we have a Django template here. Passed in as context to the template, we'll say dogs is equal to all of our dog objects. And then we do the initial query. So when we iterate over this query set, Django calls the database, fetches all of the dog objects. And then as we go through and print out their name and the name of their favorite toy, when we access dog.favoriteToy, behind the scenes, Django does an additional query. So the green, the top one is our +1 in the n+1 problem, and then the dog.favoriteToy gives us the n different queries. Another example where this comes up a lot for us in particular is using Django REST framework. So many of you may have used this before. So this is a pretty simple serializer. For right now, we're just serializing, say, the ID of a dog. And then we have a list view that uses that serializer. And for the query set, we say, get all of the dogs that belong to a particular owner. Great. So this doesn't have an n+1 query problem. Here we have our sort of +1 query, which fetches all of the dogs. But our dog serializer doesn't do any additional queries, so we're in the clear. But maybe, let's say, a month later, you say, hey, our dog serializer needs to, we want to know about the name of that dog's favorite toy. And so we add, say, something like this. And here, when you specify the source, we're saying, hey, that's the favorite toy's name. And behind the scenes, Django will do a query there. And with this sort of setup, you run into an n+1 query problem. And maybe some of these are harder to see initially because maybe you define your views in different files from your serializers. And so you don't necessarily know when you go and change the dog serializer that you have to change all of the views that use it to make sure that you fetch the dog's favorite toy. Cool, so how does Django solve this problem? So we use prefetch related. And so instead of passing in dog.objects.all to the context, we can call prefetch related and give the name and say, hey, we want to prefetch our favorite toy. And then when we iterate through all of the dogs and print their favorite toy's name, Django doesn't actually do an additional query for each dog. So how does that work? Well, what Django does do is it does one additional query for each prefetch that you specify. In this example, it was the favorite toy. So kind of how it would work behind the scenes is that it would go through, fetch all of the dogs, then iterate through that list, collect up the IDs of their favorite toys, and then execute a query, something like this, where you select all of the toys, where that toy's ID is in the list of favorite toy IDs that you just collected. Great. So how does Django do this? Like, what is it actually doing under the hood? So that's what we'll talk about next. So we'll start at the beginning for how we specify prefetches. So every time prefetch related is called on a query set, what Django does is it returns a new query set, and then there's an attribute on the query set called underscore prefetch related lookups. And basically what it does is it takes everything that you passed into prefetch related and just appends it to the end of that. So for example, if we define our query set like dog.objects.prefetch-related favorite toy, we can look at this prefetch-related lookups and see that, oh, favorite toy is there. If we were to then go and add in, say, an additional prefetch-related lookup to that, we can see, oh, the favorite toy's manufacturer is now part of that prefetch-related lookups attribute. Okay, so that's sort of where Django is storing the prefetches that you want on a given query set. So then when the query set gets evaluated, say like you iterate over all of the values, somewhere along the line, fetch all is called. It's an internal method. The first part here, where it sets result cache, let's say if we were to iterate over all of the dogs, result cache would be a list of dog instances. Then, after it's fetched all of the dogs, it checks to see if you've specified any prefetch-related lookups. And if you have, and it hasn't run the prefetching process already, then it calls self.underscore prefetch-related lookups. So we sort of trace that through. And here, this internal method calls prefetch-related objects. And it passes in the result cache, which is the list of, say in our case, the dog instances that we've fetched. And then it passes in the prefetch-related lookups that we've sort of specified along the way. So we'll continue to drill down and take a look at prefetch-related objects. So this is the primary function that Django uses to perform prefetching. So you can find this function in django.db.models.query. And I've gone through, the slides are available afterwards. I have sort of GitHub links to all the places in the source code where these things are happening. But we're not, so this function handles a lot of the kind of the bookkeeping process during the prefetch-related process. And so, for example, if you have, you know, like favorite toy, double underscore manufacturer, the prefetch-related objects function keeps track of, okay, these are all the favorite toys you've fetched, and then now you have to get all the manufacturers for those. So we're not going to be digging too much into that, but one thing that prefetch-related objects does do is it calls this getPrefetcher function. And so the primary purpose of this function is to get a prefetcher. So that makes you wonder, okay, what is a prefetcher? Well, a prefetcher is just any object which defines a getPrefetchQuerySet method. That's all. So for example, let's say we have our dog class, and we access favorite toy from the class as opposed to an instance of dog. Then we get something Django calls a forward one-to-one descriptor. Okay, that's some object. But you can look, and that object defines a getPrefetchQuerySet method. So dog.favoriteToy is a prefetcher. And so I think if there's one thing to take away from this section is this getPrefetchQuerySet method. Like, this is sort of the most important thing in defining how prefetching is going to work. So yeah, if you can remember one thing, it's this get prefetch query set method. If you just grep through Django's code base, you can find all of the instances where Django is able to or define some prefetching behavior. For when talking about prefetch related, you'll see these things called descriptors coming up, and it's kind of hard to sort of work with, say, defining new objects, which are defining new prefetchers without knowing about descriptors. And so a descriptor for our purpose is an object which implements _get, or there are a couple other methods here that an object can implement to become a descriptor. And what they do is they customize what's returned when the object is accessed from an attribute on a class instance. So that's kind of a lot to parse, but like if we use Django, like we're using descriptors all of the time. Like descriptors are what makes Django ORM work. So for example, when we have a instance of the dog class and we access favorite toy, we get a toy model instance. And in order to get that, Django can go behind the scenes and fetch that from the database, instantiate it, and return it. But that's different than here when we accessed favorite toy from the class. And so how we get this difference in behavior is through this descriptor protocol. And like descriptors are just everywhere in Python. For example, like this is how methods work in Python is if you have some function and you call _get and pass in an object, then what you get is a bound method. So that's like if you notice, accessing a method from the class, you get a different type of thing than when you access the that same attribute from an instance of that class. Okay, so going back to prefetch-related objects. So now we have a prefetcher. So that is one of the jobs of prefetch-related objects, is to find some object which implements get prefetch query set. And then prefetch-related object calls a helper function called prefetch one level. And this is really where all of sort of the work that we care about for the purposes of this talk is done. And so this function basically has this outline. So what we're passed in is a list of instances. So again, this is in our example, this would be a list of dog instances. And then we get a prefetcher, which is the thing that we just talked about. And so that implements this get prefetch query set method. So the first thing it does is it calls that method on the prefetcher. And so this is kind of the interface that get prefetch query set has. This is basically where all the sort of interesting stuff happens with respect to prefetching. And so what get prefetch query set is supposed to return is a 6 tuple with these sort of 6 pieces of information. And so I'll sort of talk about what they are. So the first thing in the tuple is basically an iterable of related objects. So when we are doing dog.objects.prefetch-related favorite toy, this rel QS will be a query set of all of those favorite toys. Then the next two things in the tuple are functions, which take one argument. And I like to think of these as taking, basically returning something like I think of as like a join value. And so they return some value which is used to associate the instances, which are, say, the list of dogs, and the related objects, which are the toys. So the first one takes in one of the related objects, a toy, and returns the join value. And so here, our join value is going to be the primary key of the toy. So given a toy, we just return its ID. Then the next one takes one of the instances, so in this case a dog, and returns the primary key of the favorite toy. So these values, using these values is how Django is going to know, oh, I should associate this toy with this dog. And it's based on these like join values. The next three things that are returned basically tell prefetch one level or the prefetch related subsystem, where do I, now that I know like how to associate, say, a toy with a dog, like where do I stick that data? And so the first one is whether or not there is a single toy object associated with a dog. And so in this case, each dog has one favorite toy, so single is true. The next attribute is a cache name. And so this is a name related to the prefetcher, and we'll see sort of how this gets used when we take these values and store them on the instance. And then finally, there is a Boolean called isDescriptor, and this applies in the case where single is true. We'll see how this gets used, but it just changes the place that the related object is stored on the instance. Okay, so this is sort of what getPrefetch query set returns, and this defines really the interesting behavior for prefetch related. So we'll go through like later in the talk and see lots of other examples of this 6 tuple returned and how you can get different behavior in Django by customizing the values returned there. Okay, so we've called getPrefetch query set. We get this 6 tuple. And then what prefetch one level is going to do, it's going to go through all of the related objects and figure out which instance they're related to. So it's going to take the, so the very first thing we do is we get all related objects, which we just call list on the first thing that was returned from getPrefetch query set. And so basically this is the only thing that the prefetch one level code does with this rel QS variable. And so it doesn't even have to be a query set, it just has to be some iterable. Django doesn't rely on specific properties of the thing that's returned there. It really just calls list on it and then goes from there. So in our example, this rel QS was going to be all of those favorite toys, right? We took toys and filtered them such that their ID was in those list of favorite toy IDs that we collected. So the next thing we're going to do, we're going to define a cache dictionary, and we're going to iterate over all of the related objects that we've gotten. And we're going to get this join value. So here, remember, this rel obj adder was a function which took in one of these related objects, a toy, and produced the join value. And so in this particular case, that was going to be the primary key for the toy. And then once we have that, we use that value as a key in this cache dictionary. And the value associated with that key in the dictionary is going to be a list. And it's going to be a list of all of the related objects, so the toys, that have that join value. And so because in this instance, the toy ID is a primary key, you're not going to have lists of, say, more than two objects, because there is only one, say, toy per ID. Okay, so we've gone through and we've built up this cache, which maps our join values to a list of related objects. And then the next thing that prefetch 1 level does is it stores the objects on the instances. So once we've fetched all the related objects, like I said, we need to store them somewhere. So it iterates over all of our instances. So this is the list of dogs again. Right here, we fetch that in our initial query, and we have that. And then here, this instance adder is this function that we talked about earlier, which takes a dog and produces the join value. So here, like I said, this is the primary key for the toy. And what we do is we get this variable called vals. So we take our cache, look up, see if the join value is in there. If it is, we return that list of related objects. If it's not, then we get the empty list. So now for every object, we have a list of related objects. So for every dog, we have a list of favorite toys. And here's where, like I said, those sort of final 3 values from that 6 tuple come into play. And so if single is true was returned from getPrefetch query set, then we sort of fall into a conditional block of code that looks like this. So we know there's only going to be at most 1 related object. So here we get that as a singular val. If there's no objects in that list, we get none. And so then we fall into 3 cases. The first one is if when you specified the prefetch, you specified a to adder. That is an optional argument that you can specify, and you say, hey, once you fetch this, stick it in this attribute. So we call set adder on our object, and to the to adder, and we get our val, which is a toy. Otherwise, if this descriptor Boolean returned was true, then you basically set the cache name attribute on the object to be this singular value. Finally, if none of those are the case, there's this fields cache dictionary, which lives on the object. And we put the value in that dictionary associated to the key cache name. Cool. So this is what happens if you return single equals true. You can control where prefetch related puts your related object. If single is false was returned from getPrefetch query set, then we fall under 2 cases. Again, if you've specified a specific to adder when you specified the prefetch, then you're going to set that attribute on the object to be that list of related objects. Otherwise, if that's not the case, then we'd have to do a little more work here. But at the end of the day, you can see on the final line, you have a prefetched objects cache attribute on, say, our instance, like a dog. And in that, you have a key as a cache name, and you set that to be a query set. And 2 lines above that query set, you've set the result cache on it, which says, hey, I've already basically fetched this data, and this is what those values are. Cool. So that was sort of a lot. But if we go kind of over everything that was done in prefetch 1 level, is we called getPrefetch query set. It got this big 6 tuple, which defines what it's going to do. We took that data and went through and associated all of the instances with their related objects. And then finally, we stored those related objects on the instances. And how we did that depended on those values returned from getPrefetch query set. Great. So once those are there, how do we make use of them? How does Django make use of them? And And so this depends on which particular prefetcher you used. But in the case where we had this dog.favoriteToy, this descriptor will call self.field.getCachedValue, and this looks in the fields cache dictionary to see whether or not the favorite toy has already been fetched. So the code in this descriptor sort of knows where the prefetch related code is going to put the related object. Similarly, managers on instances will check this prefetched objects cache within their get query set method. So, if you were to do something like toy.dogset.all, right? This is all of the dogs which have this particular toy as their favorite. That will check on the toy's prefetched objects cache to see if this query set that already has all the dogs there has been already fetched. So that was kind of the main, kind of landmarks in the prefetching process. One, you specify the prefetch lookups. Those get stored on the prefetch related lookups on the query set. When it's evaluated, it calls prefetch related objects. This function goes through, finds a prefetcher. That's one of these things which defines get prefetch query set. And then the prefetch one level takes that data there and sort of joins the initial objects you have with the related objects that it just fetched, combines those together, and then finishes its job. And then when there's additional code, let's say in these descriptors or these managers, that know sort of the right places to check to get access to these prefetched values. Okay, so that was a bit of a whirlwind tour. But now I sort of want to talk about these sort of case studies and like how we can actually like make use of this information in our code. So the very first one I want to talk about is like, let's say suppose we store our user model in a different database than the dog model. So here we have in database 1 our Django user model, and over in database 2 we have our dog model, and it has a user ID field, which is a positive integer. So we can't use a foreign key because you can't have foreign keys across databases. Django doesn't like that. And so, but we would still like to be able to use this in sort of a way that feels like it's actually a foreign key. So in particular, we'd like to be able to do things like, hey, for all of the dogs in user.dogs.all, we'd like to print the dog and the dog's favorite toy's name. But because we want to be able to do things like that, we also want to be able to do things like user.objects.prefetch related, and we want to fetch all of the dogs and all of their favorite toys. Great. So this is sort of our scenario. And so how do we do this? There's a couple of steps. The first thing we have to do is define a manager which implements this get prefetch query set. So this is our prefetcher. And this is the thing you'll get when you access user.dogs, right? You'll get one of these managers so that you can say .count or .all and do all of that with it. And sort of the two functions we'll be interested in are, like I said, the get prefetch query set to define the prefetching behavior, and then also get query set so that we know, like, okay, once the prefetching is done, how do we actually get that in use by the dogs manager? The next piece we have sort of in this puzzle is a descriptor. This, like I said, implements this get _get method. And when it is accessed from a class, so capital user.dogs, it will return the descriptor. But if it's accessed from a, say, user instance, like lowercase user .dogs, it returns one of these dog managers. And we'll pass in that instance so it knows which particular user you're talking about. And then finally, we set this dogs to be our dogs descriptor on the user. So going back and filling in the missing pieces, we have to define this get prefetch query set. So it takes in a list of instances. In this case, it will be a list of users, an optional query set. But the main thing we do is we go through all of the user IDs and collect them into a list. And so here this list is called owner IDs. It's a list of integers. And we return the 6 tuple. And so the very first thing is going to be basically like dog.objects.filter owner ID is in this list of integers. So we don't even need to know about, like, we don't have to have a foreign key there, right? This query executes on database 2. You're just getting all of the dogs that have their owner ID in this list of integers. Like Django can do that, no problem. And now we have to come up with the join values. And we're going to basically join on the primary key for the user. So when we get a related object like a dog, we return the owner ID. And we get a user, we return the user ID. A person can have multiple dogs. So we'll return false for single. We'll cache it under the dog's name. And is descriptor doesn't really apply in the case when single is false, so we'll return false here. And this basically is everything you kind of have to specify to the prefetch related system in order to get the things that we want to do to work. And then finally, we also need to implement this getQuerySet method, which the first thing it tries to do is access the dogs key in the user's prefetch objects cache attribute. So when we perform the prefetching, we'll get a list of dogs, and the prefetch related system will put it in the, for each user, it'll put it in the dogs key in their prefetched objects cache attribute. If it's not there, then we sort of apply the default behavior of the manager. And so now, with those sort of things in place, you can do things like this, where this is only going to do 3 queries, one to fetch the users, one to fetch those users' dogs, and then one to fetch those dogs' favorite toys. And so that's going to, basically this looks exactly like it would if the dog objects and the user objects were living in the same database and you had a foreign key for this particular pattern. So the next sort of scenario I want to look at is that, hey, there's really nothing special about those integers we used as a join key in the previous example. And so you can basically sort of join any 2 models as long as you can get values that are equal between them. So specifically, suppose we're able to define a dog's classmates as all of the dogs that were born in the same year as that dog, okay? And so in our code, like this, maybe we want to iterate through all of a dog's classmates and print that classmate's favorite toy's name. And so here, if you aren't able to do any prefetching, you get an n+1 query problem. So I'm going to sort of skip all of the part with the manager and descriptor before and just sort of go into the sort of main piece, the getPrefetchQuerySet method. And so how's this work? So we get a list of dogs, and then we collect all of the years of their birth dates. So here, years will be a list of integers, and then we define the data. So the first bit will be all of the dogs which have a birth date in one of the years that we've collected. And then we have to, how are we going to associate a dog with its classmates? Well, we're just going to use the birth date's year. And so here, because the the instance and the related objects are both dogs, we have the same, these same functions to get these join values. And again, you can have multiple classmates. We're going to cache it under the classmate's name, and is the descriptor doesn't apply. So, other than all of the sort of kind of boilerplate to get the managers in place, this is really all you need to do to be able to prefetch all of the dogs that have the same birthday as your particular dog that you're interested in. Okay, next one we kind of want to look at. So we recently had to add support for adding translations to fields in Django model fields. Rover kind of expanded into Europe, and we needed to support a lot more languages. And we have some models which have fields which store English text, and we want to be able to present that text to users in their preferred language. So we went with a approach that uses one table to store all of them. So the main things in this table are a generic foreign key to the object that we're translating, a language code to specify which language it is, a field name to specify which field on the content object that we're translating, and then value, which is the translation itself. So one particular example of that in our system is a dog breed. So a dog breed has a name, and we want to be able to translate that. And so we can use kind of the reverse relationship between the generic foreign key using generic relation, and say we could prefetch all of those, but it does have the disadvantage that you're prefetching every language, the translations for every language, even though you may only need one. So we'd like to be able to have something called like active translations, where we only want to prefetch the subset of translations which correspond to the active language in the sort of request response cycle. So if a user's preferred language is French, we only want to fetch the French translations. Additionally, since a large percentage of our traffic uses English as a primary language, we don't want to necessarily take this additional query overhead if if we're not actually going to use any of the translations. We don't actually want to do those queries. Cool. So how do we get prefetch related to do this? So in our sort of the relevant get prefetch query set method, we do something like check if the active language is equal to the default language, and that's what we'll assume that the language that the values in the table are stored in. And if you're equal to that, then we're just going to bail out early, and we're going to return an empty list here. And it doesn't matter really what we return for our join values, because there's nothing to join. And in this case, we can prefetch the active translations, but Django won't do any database queries. We don't have to go to the database and come back. And then additionally, for that sort of manager, we get the query set, and then we just have to take that query set and filter it by the active language during the request response cycle. So we're able to sort of transparently get field translations without having to do a whole lot of extra work and extra queries. And the final one I want to talk about is mainly more to showcase kind of the flexibility within the prefetch related system, as opposed to like this being a pattern that I would recommend in your code. But let's say there's a third-party dog date service which provides a HTTP API that lets you fetch possible play dates for your dog. So a request looks like this. We make get requests, and we pass our dog ID as a query parameter. And we get back a list of dictionaries, basically. And we have the dog ID as a key in there, and then play dates, which is our list of URLs. And their HTTP API also happens to support multiple dogs per call. So if you pass multiple dog IDs, you get multiple dictionaries back with their IDs and their playdates. And so suppose we have code which looks like this. In our dog model, we have a dog dates external ID. So this is for a dog in our system, what is the ID in their system? And then we have a available playdates property, which when you access it, it goes through, makes a GET request to this URL, and then returns basically the playdates field from that response. And so now you have something like an n+1 like request problem. So you're not doing queries to a database, you're making HTTP requests. And so if you wanted to go through all of the user's dogs and print the available playdates, then you get one HTTP call per dog. This looks like something that we can solve with prefetch related. And so we can actually do that. So in our get prefetch query set, here we get passed in a list of dog instances. And so we can build up one of these URLs that has all of the dog IDs as query parameters. And then here we return, well, the first thing we return is we make the HTTP call, get the JSON response. That's a list of dictionaries. And now we have to find some way to associate that list of dictionaries with the dogs. And so we'll use that dog ID data in there. And so the first one takes one of these dictionaries, gets the dog ID, turns it into an integer. And the second one takes one of our dogs and returns the dog dates external ID. And we know that there's exactly one of these dictionaries per dog. So is single is true. We'll store it in say underscore available playdates. And now you can do something like this, where you do dog.objects.prefetch related available playdates, and behind the scenes it will make a batch request to this API. And then you no longer have the n+1 problem that you would have if you didn't do something like this. So that was mostly what I wanted to go over today. This week I'm going to be working on getting some of this boilerplate code that you need to write in order to get your own sort of custom prefetchers into a third-party package called Django Prefetch Utils. So I'll be working on that this week and at the sprints. And I'll be around if you're interested in things related to data fetching or prefetch related, anything like that. I'm happy to talk on that. So thank you.